Kinesiology 230, Chapter 5, Presentation 7, still in chronic adaptations. Now we're into skeletal, tendon and ligament, and cartilage adaptations due to chronic or long-term training. We're still in a section that started on page 75 of the book. And here we are. So when we talked about the different areas, this is kind of what we've worked through. We did the first two, neurological and muscle tissue. Now we're in these three, and then you'll see these four later on. Again, I would still go back and try to review some of the material in the chapter because it's, I'm going through this at a rather quick pace, and I would take the time to go back and review this or even have the book side by side while I'm rambling on through these presentations. So we talked about the bones before, and when you look at the skeletal system, you have the big beefy bones, and the bones themselves, they're dynamic in nature. They're not static. There's a lot going on with them. Sure, they provide structure and support for the human body, and they allow through the articulated surface or articular surfaces up here, they allow movement to happen. But also bones are a storehouse of minerals, and they're also a blood-making factory. And it's kind of interesting to say it like that because you wouldn't think like your bones are where the blood's made. But the blood in the body is made through it's called hemopoiesis, Hemopoiesis. And that's done within the bone itself. It has to be the big beefy bones. So it's not like in your finger, it's going to be in the top of the femur, for example. And when you look at the storage of minerals in the bones, osteoporosis, which I'm sure is a term you've heard before, osteoporosis is this kind of demineralization of the bone, where you slowly over time have this loss of minerals within the bone itself. And I can cite many examples of clients who've come in, female especially, who listed that as a cause or a concern. And we talked through that. And strength training, especially load-bearing exercises, help offset or at least abate some of the effects of osteoporosis. And your bone tissue is influenced or affected by strain, whether it's bending of the bone or some compressive forces on the bone itself. Those are the types of forces you need to be able to stimulate this bone growth. And it's not something that happens overnight in terms of osteoporosis. It's a almost like an erosive process. And therefore, when you're working with clients to help them with osteoporosis, it's not going to be an overnight process either. It's something you have to work on slowly but surely. Now, within chronic adaptations, you have the bone itself now can be influenced by a number of different forces. And the book lists that bending of the bone stimulates bone formation. I would tell you when we go from an unloaded position, this is from another class, this is from your 236 book, you have tension, which is kind of the pulling of the bones. You have compression, which is kind of like pushing down from top to bottom. Shear, which is back and forth. Bending, which is the book is advocating for bone stimulation. Torsion, and then combined torsion and compression. I would tell you, at least from some of the research I've seen, sure, bending is great. That's part of it. But these other forces definitely help the cause. They definitely help offset some of the issues or the process of osteoporosis. So mostly compression, shear, torsion, bending, those are your winners. Unloaded, obviously nothing that's like a deconditioned person. And then tension to a lesser degree, not so much. All right, so when you think about when you're working with your clients and what you would do with them, you probably do exercise where it's load bearing, they're standing, maybe you have them holding a weight, they're doing goblet squats, things where they're putting load on the system that requires their body to be able to move in a way that'll stimulate some of this bone growth. All right, so tendon and ligament. We already talked about tendons and ligaments, and we're talking bicep curls. You have bundles of connective tissue that are made from collagen. They describe it as low cell count, therefore it's a low blood flow to that area with low oxygen and low nutrient requirements. Now, acute bouts of exercise will stimulate collagen, and you'll have clients that'll come in and they're probably doing some kind of collagen supplement, or maybe they've had some kind of collagen supplement suggested to them by their doctor. What you'll have is with tendons and ligaments, data suggests that eccentric loading stimulates growth. And we talked about tendons in chapters 1 and 4. So if we look at the biceps, right, you have the biceps brachii itself, and then the bicep has a tendinous attachment up towards the top in here, one for each head, and then it comes together into one tendinous attachment down here, and that's on the forearm, very much like what we saw right here. So this is a forward on view, this is a side view, and we also had this view down here where we talked about the tendons down here. So looking at this, these are the main areas that we're talking about when we start talking about tendons. It's the connective tissue that you have in the body, and it responds to training. So with cartilage, you have three main types of cartilage. They didn't really dig into this too much in the book, but you have I mean, they went into a little bit. They didn't dig into it a lot, but you have the hyaline cartilage, which is like for joints, ribs. They're used for articulation, like what you see here in the knee. This is the knee from the front, and you have cartilage that's built in there in terms of the meniscus or menisci. You have elastic, which is found in the ear and the epiglottis, and it's for flexibility. Fibrocartilage, which is or are like the discs in your back, and they are for like the ability to handle a lot of shock absorption, if you will, and they're very durable. You know, you'll have clients who will come in and say, I have a lack or loss of cartilage, or I tore a meniscus, I have a disc herniation in my back. You know, a disc herniation would be like a damage to annulus fibrosis. That's the technical term for what encapsulates the disc itself, as that fibrous material that encapsulates the disc in the back itself. But you'll have many clients that will come in with any number of these conditions, and you have to be able to work with them. But it's something where it lacks these very things. It lacks blood vessels and nerves. It doesn't really have like a high blood flow for any kind of like nutrient exchange, but it serves these different purposes depending upon type. And it could be something like this, where it's more for compression and also articulation, meaning the knee slides over, the distal end of the femur slides over the tibial shelf, and it allows that articulation in the knee joint there. Or you have something that's very much like for compression in between the vertebrae. So cartilage itself has the ability to adapt, but to a lesser degree, because think of it in terms of it doesn't have the same blood flow as like muscle does. And then tendons, to a lesser degree, do not have the same blood flow like muscle does. So the adaptations there are not as pronounced as with muscle, but there are still some areas of opportunity. All right, guys, signing off and moving to the next one.